Hello everyone, Richard here. Just wanted to quickly give you an update on the universal filament spool standard that I proposed a few months back. I've been doing a lot of discussions with people, having some great talks about the standard, about possibilities for making standard real sizes for 3D printing and the difficulties and challenges with doing that. So here's just a bit of an update for you of where we're at and some of the ideas that have come out that are really starting to shine. Okay, so first of all, I proposed that we had a standard filament size, and this is the filament spool size, so it can fit onto home 3D printers and industrial 3D printers without having all different types of spools, sizes, widths, and coil diameters. Sometimes the coil diameters were getting so small that they're actually causing problems with 3D printing because they were so tight. It does make a difference what types of materials you're using, but generally there was issues coming from different types of off-the-shelf spools that you can buy that were materials being wound onto and then sold as 3D printing material. So the idea was to try and figure out a way to have a standard that everyone would generally agree to or want to adopt, and see whether that could be pushed or not necessarily pushed, but just generally adopted by some of the industry people who are making filament and some of the people who are making machines. So we went about talking to various companies about the challenges they face, and the biggest issue that we saw was really that the actual filament spool itself. Some of them can be very, very big and heavy and take a lot of plastic. A lot of them are made of plastic, and actually that's quite a waste because they get disposed of, they get thrown away, and you're paying for them when you ship that around the world or when you buy it from your local supplier. So the first thing we wanted to really look at was how we make a cheaper or less heavy, or both, hopefully, and ecologically friendly as well, so something that could be recycled would be great. The idea was to make it also take up a lot less space. At the moment, some of these spools, this one you can actually snap apart and it's in 3 parts. Most of them are just injection molded. The ColorFab ones are an injection molded piece of polycarbonate, which looks fantastic, but it's quite an expensive spool. It's very high quality, very impact resistant, but it's a real shame that most people will actually just throw them away because they can't even really be recycled in any particularly good way. So the idea was to try and find a way to make those more easier for people to manufacture and to sell and distribute and hopefully recycle. That led to some really good discussions about the use of cardboard and all sorts of other types of materials, so almost like paper mache type materials, to all sorts of other interesting ways to reduce the weight and size of a spool. One of the best conversations I had was with ColorFab, and they had spent quite a long time investigating and looking at this problem as well, because they know they want to produce something that looks great, but they also want to reduce the weight and the impact on the environment and various other issues that are wasting a lot of plastic with spools for a consumable item has. So they introduced me to a company that was doing a really interesting material that was called biofoam. It's a type of PLA, and it's in bead pellet format, and these special pellets actually expand just very similar way to the way polystyrene works, expanded polystyrene works. So polystyrene's really not good for the environment and has some horrible, it sits around in the environment for a long time, so really not a good thing. It's also quite brittle. It wouldn't be any good for a filament spool, and it produces all sorts of bits as it breaks off and that sort of thing. So originally that was never an option, but it led to thinking about the way biofoam could be used to produce a spool. And what's really interesting, there's other types of foaming materials as well. There's expanded polypropylene that's used in computer packaging quite extensively. But again, that's quite a flexible material and quite a dense material and difficult again to recycle and break down, that sort of thing. So the good thing about biofoam is that you can it produces a part that's very, very lightweight, so probably only about a quarter of the weight of a normal spool, because these parts basically just inflate with air. And how it works, it's quite an interesting system. You produce a moulding tool out of metal, and you actually drop a handful of these beads, or the right amount of these beads, into the tool, seal the tool up and inject hot steam, very hot steam, high pressure steam, and that expands immediately the pellets into the shape, and you end up with a moulded part. Now, the one thing we spent quite a lot of time talking to a lot of people about was the amount of space that spools take up. And the idea again there is to make a tooled part that was a single part that you could use two sections of to clip together to make a spool. So actually your tooled BioBead made spool would only be half of this, with a clever little clip and a slight conical to allow it to lock together and to come out of the spool, but also allow it to turn this part over and stack, so they could be stacked up on top of each other and take up a lot less space in packaging and storage. So it's sounding like a really interesting way forward to use something like BioBeads or Biofoam to produce a very, very lightweight, hollow but very strong spool that can be clipped together or unclipped and stacked up, or actually manufactured and put together on demand as the reels are being manufactured. And again, one of the really great things about the Biofoam is that it produces a part that's just like a PLA printed part that you'd have on a 3D printer. So I really hope you like the sound of where the spool standard project is going. And at this point, it really is down to people deciding to adopt these types of innovations and systems that are out there and available to be used for this type of consumable item. The use of Biofoam and these beads that can expand and produce very strong, very lightweight spools for 3D printing and other types of materials, and even packaging of all sorts of types, is out there. And it'll be really good to see one of the manufacturers use this standard. We've done a lot of canvassing of opinions of what people would like for their spool sizes, shapes, dimensions, all that sort of thing, which will go into a document that the 3D Printing Association will put up on their website as an open standard, basically, that was basically the feedback of as many people as we could talk to and contact about 3D printing and the use of plastic filament and spools in 3D printing. So there'll be a lot of information in there, and links and discussions about BioBeads. I do hope a manufacturer will decide to go down a route like this and produce a sustainable spool that can be have all the benefits that I've discussed, along with all sorts of positive benefits for the environment as well. So I hope you've enjoyed that, and it's something that I'm really very keen on, is trying to produce common standards for 3D printing. There's all sorts of different variations at the moment, which is great, and we need that, but we also need a few standards and better ways of doing things. So this was just the first attempt to try and rationalize spool sizes, because it really is a problem for some people, a problem not so much of a problem for others. But there's no doubt that a standard spool size would help machine manufacturers, machine developers, and all sorts of people in the 3D printing industry produce better machines for the consumer and for the industry. So I hope you found that useful, and I'll put some links and possibly some more information up on the 3D Printing Association as soon as we possibly can. So thank you ever so much, and see you soon.